Hey everybody, this is Mark Phillip from Studica, and today I'm going to be showing you how to create an isometric camera and an isometric based character controller. By the end of this tutorial, you should have something that looks like this. You can use WASD to move this cube around in an isometric view, and the controls work the way you would think that they work. And what I mean by this is that if you press D, you move to the right. If you press A, you move to the left. Instead of moving upright when you press D or moving up left when you push A. So you might have run into these kinds of problems if you've been working on an isometric game, so hopefully I can help you solve these issues. So let's go ahead and jump into that. Now before I get started, I want to talk a bit about what the issue is here with isometric games, because it might not seem too apparent up front. But you'll notice my really bad MS Paint drawing here. I have my world axis labeled. So in an isometric game, you have everything kind of tilted at a 45-degree angle, right? So there's kind of this illusion of depth. And it's almost as if you're looking from an overhead view if the camera was tilted 45 degrees. That's essentially what an isometric game is. Now the problem happens when you have, say you're trying to implement controls for a player's movement. So when you rotate your camera, your world axis is not going to change. So your x-axis is now pointing in the upright direction based on your own perspective. Your z-axis is pointing to the up left direction. Your y is still pointing straight up. Now the issue here, if you can think about it, if you just tried to implement a character controller that took WASD as input, and you said when I press D, move vector 3.right, that's actually going to be using the world axis right, and your character is now going to move up and to the right in this direction instead of straight to the right in this direction. So you can see my desired player axis is that I want movement to basically operate this way, right? So if I press my D key on my keyboard, my player will move directly right regardless of the world axis. And same with the z-axis where I can move up and down. So basically we need to account for the 45-degree difference between the world axis and the sort of axis that we want our player's movement to happen on. So the first thing I'm going to do is create a new project. I'm just going to call it ISO. I'm going to leave it on 3D settings, and I'm going to hit create project. So the first thing we need to do is create a scene that our player can walk around on. So we're going to go up to Game Object, 3D Object, and create a new terrain. I'm going to zoom out a bit here so I can see my terrain. I'm going to click on my terrain, and I'm going to choose the settings icon here under the terrain components. And I'm going to go down to resolution section and change the width of the terrain and the length to 50 each. So I'll wind up with this much smaller piece of terrain here. Makes it a little easier to see our character move around. Now what I want to go ahead and do is delete my main camera. We'll be making our own camera in a moment here, but before we do, we need to create an empty game object that is going to act as a parent for our camera, and it's going to be applying the isometric rotations that we need. So on this game object, I'm going to rename it to camera target. I'm going to go ahead and center this at the origin of the world, so I'm setting all the positions to 0. I'm going to set the X rotation to 30. I'm going to set the Y rotation to 45. So this is going to essentially create an angular pointing game object, and then we're going to create a child of this object of a camera, which will actually, show us our scene. So in order to do this, what we're going to do is right click on the camera target in our hierarchy, and we're going to create a new camera object here at the bottom of the list. Now the first thing, and this is an important step or else the code won't work, you need to go up to the tag here because it starts off as untagged, and you need to put this on the main camera because this will be our main camera that is going to be providing the look for our whole scene. Now the next thing we want to do is change the projection from perspective to orthographic. And a note about this is that you don't have to do this step if you don't want to. This is kind of a stylistic decision. Orthographic is going to make things look more two-dimensional or more flat, I guess you could say, whereas perspective will still maintain some illusion of depth about the scene. So it kind of depends what you're looking to do. So at this point we can move our camera target around to try and fit the terrain into our scene. So I'm going to click on the camera target. I'm going to activate my transform tool here, and I'm going to move it up. And what I'm going to have to do is make sure I can see more of the scene. So I'm going to click on my camera. I'm going to change the size value here. I'm going to increase it until I can kind of see more of my terrain. So this is modifying the orthographic size of the camera. Basically, you'll notice as I change it, if you look here on my scene view, you'll notice that the boundaries of the camera and what it can see are changing as I change the size. So when I go lower, I get a much more narrow focus, and as I go higher, I get a much wider focus. For this demo, I'm going to stick to about 20. I want a wider look here so we can kind of see everything. And you can still move the camera target around if you want to maybe center this more like such. I'm going to leave mine right about there. So that's about it for our camera. And what I'll end up doing now is creating a 3D cube game object by going to Game Object, 3D Object Cube. And let me pull this up. Let me look at my scene view and make sure it's on my terrain here. So once you reposition your cube, you basically just want to make sure that it's sitting over the terrain and that you can see it here in your game scene. So it already has a box collider. That's good because we'll need one. And now we also need to add a rigid body component to this so that it will actually interact with the terrain and not just fall straight through it. Now before we make our script, we want to add some custom inputs for ourselves. So we're going to go to the Edit menu, Project Settings, Input, expand out the axis arrow here, and change the size from 18 to 20. And your two new buttons show up at the bottom here. They're just reproductions of the cancel option. Now we're going to change one of these to horizontal key, and our positive button will be D, our negative will be A, and our second one is going to be vertical key with a positive button of W and a negative button of S. So basically we'll be calling on these in our code to determine if we're moving up, down, left, or right, and then we'll be running some math across those values to make our movement happen. So at this point we should be able to create our script. So let's go to our cube game object and click Add Component, and we're going to make this component called Care Controller, as you see here. We'll click New Script. It's going to be a C# script, and we're going to do Create and Add. Now let's go ahead and open this script up in your IDE of choice. I'm using Visual Studio. Now I do want to give a shout out real quick to a user on the Unity forums by the name of Evil Warren. He pretty much came up with most of this solution, and I sort of just modified it very slightly for what I wanted. So the first thing I'm going to do is create a serialized field so that I can modify this in the inspector without making it public. And it will be a float called move speed, and we're going to equal that to 4f. And you can change that to whatever you want depending on how much move speed you want. And now we're going to have two vector 3s named forward and right. And both of these will be used for dictating our player's forward and right vectors at any given moment, because those vectors will be differing from the world axes. So we need to kind of create them ourselves. In our start function, we're going to go ahead and set forward to equal camera.main.transform.forward. So we're starting this off by saying that our forward vector is going to equal our camera's forward vector. And our forward vector will be referring essentially to our upward and downward vector. So to illustrate why this is important, I'm going to change my rotations to local. So if I look at my terrain right now, my terrain's still aligned normally, right? There's no rotation. Our forward vector is this way right now. So normally if I was to just tell my cube to move forward when I press the W key, my cube would move this way. And that's not what we want in an isometric game, right? If you press the W key, we essentially want our player to move more this way, right? So the reason that we're using the camera's forward vector is because let's look at our camera. So our camera is pointing in the direction we want for our forward, right? This is essentially the kind of motion we would want our forward movement for our player to be. So that's why we're aligning our forward vector with the camera's forward vector up front. And the next thing we do is we set forward.y equal to 0. This is just for clarity purposes. We're basically ensuring that our y value is always going to be set to 0. And then what we'll do is forward equals vector 3 dot normalize the forward vector. Basically, when you normalize a vector using this function, it keeps the vector's direction but sets the length to 1 or 0 depending on many different factors. For the sake of this, we're just making sure that the length is set to 1, and so we can use this vector for motion. Then we want to do right equals quaternion.euler new vector 3 0 90 0 times the forward vector. So the quaternion.euler function is basically creating a rotation for our right vector, telling it to be basically rotated 90 degrees around the x-axis. And then we multiply that by our normalized forward vector, and the net result here is that we'll wind up with a right vector that's facing roughly negative 45 degrees from the world x-axis. So you consider that would be somewhere in the 4th quadrant if you're looking at the world axis in a 4-quadrant setup. Now inside of our update function, I'm going to do an if statement for input.anyKey, and this is going to detect if any key is being pressed at any given time. And inside of the if statement, we'll be executing a function called move, which we will create right now. Now inside of our move function, we'll create a vector 3 called direction. And it's going to equal new vector 3, and inside of here we'll be assigning input.getAccess horizontal key to our x value. We'll have a y value of 0 and an input.getAccess for vertical key on the z axis, or the z value. So basically we're saying our new direction is equal to whatever our value is on our input for our x and y values at any given time. So a bit about input.getAccess. Our horizontal key positive key is D and our negative key is A. So if we press D, this function is going to return 1.0. If we press A, this function is going to return negative 1.0. And that's the same with getAccess vertical key, just the keys are swapped. It's W and S instead of A and D. So down here we say vector 3 right movement equals right times move speed times time.delta time times input.getAccess horizontal key. Now what this is basically doing is saying what our right movement is going to be. We're taking our right vector, which we created up here. We are multiplying that by our move speed variable, and we are multiplying that by time.delta time to create a more smooth movement. And then we're multiplying all of that by input.getAccess horizontal key. So the net result here is that this will either move us in a positive or negative direction depending on our input.getAccess, and it will be moving us however quickly move speed and time.delta time are allowing us to move. And then you do vector 3 up movement equals forward times move speed times time.delta time times input.getAccess vertical key. So we have pretty much the same logic here. Main difference is we're now using our vertical key input and our forward vector to handle what our up and down movement is. And then the last bit here, and probably one of the most important bits, is to create vector 3 heading, and this is going to equal vector 3 dot normalize right movement plus up movement. This is ultimately going to be giving us our total direction that we're going to move in. So by combining right and up movement and normalizing those vectors, we're creating basically a direction that our character can now point to when we're moving around. And the way that we actually do this is by saying transform.forward equals heading. So typically your forward vector of your transform is actually the z-axis in world space. And that's the reason that we couldn't just use the forward vector to move our character, because if we did, again, we would be moving this direction because this is the forward direction in world space. So that's why we tell our forward vector to now equal our heading, which is going to be a combination of our rightward and upward movement, which is itself already rotated the way that we need it to be. So then to actually make movement happen, we say transform.position plus equals right movement, and then we say transform.position plus equals up movement. These two lines right here actually make our movement happen, whereas this line right here makes our rotation happen. And so I'm going to go ahead and save that script, and that should be all that we need. Now if I go back into Unity and click play, you'll notice that I can move around using WASD. And again, the key here is that if I press D and hold it, I move right in the way that I would expect to be moving right. I'm not moving this way when I press D, I'm moving this way. And additionally, when I press W, I'm moving straight up instead of moving the way that my world axis would have me normally move. And if I press S, I'm moving this way instead of moving this way like my world axis would normally do. That should be the end of this tutorial. I know it's pretty primitive, but hopefully it gives you a starting point for your isometric game that you might want to be developing. If you have any questions or comments, feel free to leave them in the comments section. If you have some better ways of doing this, feel free to leave that information on the page. Yeah, so hopefully you learned something, and thanks for watching. Have a good day.